Hello everyone, welcome back to SAT Math question of the day. Hector used a tool called an auger to remove corn from a storage bin at a constant rate. The bin contained 24,000 bushels of corn when Hector began to use the auger. After 4 hours of using the auger, 19,350 bushels of corn remained in the bin. If the auger continues to remove corn at this rate, what is the total number of hours Hector will have been using the auger when 12,840 bushels remain in the bin? Unlike yesterday, it doesn't seem like a pattern would be the way to go on this. T bushels removed. Okay, so this is a linear equation word problem with a little bit of a twist. Things are going down. So the relationship is, Seth's doing it too, y is equal to mx plus b, but x is time after starting to use the auger. Now, when time was 0, there was 24,000. So it's plus 24,000. Well, kill that 24,000. Just make it 24. We'll work in thousands, okay? So the number's easier. It's less time in the calculator if we need it. Now, after 5 hours, so 19.35 is the point that this equation has to satisfy. Oh, that's a cute way of doing it, actually. We can consider the m the unknown and actually calculate the slope using this. We don't usually do that. Usually we calculate the slope and then get the y-intercept. But we can certainly calculate the slope, the m here, by plugging in 19.35 is equal to m5 plus 24, which essentially comes down to the same thing. It's essentially the same thing as here, right? So it's 19.35. The slope is 19.35 minus 24 divided by 5. So the slope is negative 0.93. So we have our equation, negative 9.3 plus 24. And they want to know at what x value is the answer, is the output 1812.84. So we have to solve this equation for x. So it's 12.84 minus 24. There's a minus sign here, divided by 0.93. And we get 12. If you're schleppy about the minus signs and stuff, you could just let common sense rule. On a school test, you cannot do that. But here, you see, I forgot the minus sign. So 12.84 minus 24 was a negative number. You divide by 0.93, you get a negative time, which makes no sense. So there was actually a negative sign here. But, if you forget and you realize, I just got to get this done, you don't have to sit there and put the negative sign in there. You could just put the negative sign in the calculator. So, 12. So, if you go back to yesterday's video, there was a pattern to a problem very similar to this. But this one, I don't know if there's a pattern. Doesn't seem like there is. These numbers, it just doesn't seem like a pattern. By the time you look for a pattern, you might as well just do the problem. So that's doing a lot of writing. You can also use Desmos to figure out what the equation is. We did that yesterday. I don't know if we need to do it today. So if you want to see how to use Desmos to write a linear equation given the table x, y, go to yesterday's video. So we don't have to redo it today. Seth, you're still writing. Do you have any other comments on how to do this problem, either more efficiently or another point of view of it?
Well, I'm doing it, figuring out. So the slope is 4,650 divided by 5.
Okay.
Right?
Whatever. Yeah. I guess it's 930 or 9.
And then you divide
it's 900.
11,160 by the slope.
I don't know. My stuff is sort of confusing, but I think your thing is even more confusing. Where's your linear equation? Y equals mx plus b.
I don't use that.
Really? Oh, so how do you do it?
Ah. Well, what I did was, thing is, the what's linear is the number of bushels removed
Yeah,
as a function of time.
right.
Oh, were you doing it number of bushels that remain as a function of time?
Yeah.
Okay, so okay, good. So you could do it. You did it with terms of where y is the number of bushels removed.
No, remain.
You did it as where y is number of bushels that remain as a function of time.
But frankly, I was lucky because I wasn't
And I
paying all
did
that
it in
much
terms
attention.
of, I didn't even finish doing it, the number of bushels removed as a function of time. The
Okay.
number of bushels removed is a linear function of time with no constant.
Okay.
So I figured I'd calculate the rate and then find out how many bushels removed. Then I calculate how many bushels removed are at the end by subtracting by how number that remained from the original number and then dividing it by the rate.
Okay.
So I think yours might be easier.
I was sort of lucky because I wasn't paying 100% attention to that. And if they wanted to make the problem harder, although they say this is a difficult problem, they would have switched it in the middle of the problem. But
Yeah.
everything here is how many bushels remain. 24,000
Yeah.
remain.
Okay, that makes sense. Yeah. So
Remained.
yeah, I think I like your method better because mine entails more subtractions.
Yeah, and more thinking.
Yeah, it entails more
Yeah.
subtractions to put the numbers into the calculation.
Yeah.
All right.
Yeah. Okay. So this is a pretty classic way of thinking of. Well, what's not classic is recognizing that it is a linear equation. We'll get to the main point of the question in a moment. Again, if someone wants to write this equation, y is equal to negative 0.93x plus 24, or you could work in thousands if you want. You can do it in Desmos. Look at yesterday's video. So, should we? I guess we could look at today's questions. Is a calculator useful? Well, a calculator is useful. Yeah, in doing these little calculations here, these little calculations. And if you're going to use Desmos to do regression, yeah, of course, a calculator would be very helpful.
So, where's your answer?
It's 12. 12. My answer. The answer to the problem is the solution to this equation. Here. 12.84 is negative 0.93x plus 24.
Oh, 0.93, yuck.
0.93. Yeah, I'm working in thousands. So this way you don't have to type in extra zeros.
So
So I did that. I solved this using a calculator in my head. You subtract 24 on both sides, you get a negative number. You divide by negative 0.93, and you get 12.
So where'd you solve? So you solve for x.
Yeah, you solve this equation for x.
Okay, where is your? It's a good idea to write x equals.
Fine, x equals 12. It is a good idea.
You never wrote that, so your answer was never written on the
Okay, now
display.
I did. No, I circled the answer. I circled D.
Oh.
I circled D.
Oh, you circled it.
I'm sorry.
All right.
Yeah. Okay. Start with a guess. Actually, you can start with a guess. You can actually try all of these. Notice that they are penalizing people who do that because they put the correct answer at the bottom. So you will have sat there and have to do 4 calculations in order to confirm that 12 is the answer. You certainly can start with a guess. You can just... Actually, so you have to get the slope anyway. Yeah, it's not really practical to start with a guess. How does this differ from a school test? No, you can easily get a question like this on your school test. Is there a pattern to this? Not likely. Possible, but not likely. What's the main idea? The most important of these questions. The main idea is negotiating a linear equation word problem. Recognizing that it is a linear relationship between the variables. figuring out what, then dealing with that in one way or the other. Yesterday we used a pattern. Today you write the equation and you go from there, but you have to be really careful not to be confused between the remaining and how much you still have to take out. They could really confuse you, or you can get make mistakes by not noticing whether the amount is remaining or whether how much amount was removed. And they could switch things around. So really important to read the word problem carefully. Okay, so should we see what they did and how they did it? And then let's see if 12 is the answer. Never know. Okay. 12. Here we go. D, 12, yes. Okay, so this is how they do it. They get the slope, they get the amount removed, the constant rate of removal. It's a negative, but they don't use a negative. They say of removal. Removal means going down. So they don't need the negative sign because they have that. Okay, they continue after X hours, you will have removed this. Huh. Right, so then this is the equation we had before. Notice that they added the negative sign there. Okay, and then you solve for X, which is exactly what we did. We had 12.84 is equal to negative 0.93x plus 24. So it's the same thing. Yeah, then they explain how to do it. Yeah. So, yep. Okay, so it's pretty standard. They don't mention that you could use Desmos to use a regression to write the formula for you or any of that. Okay, if you want to see how to do that, look at yesterday's video. Okay, so I'm Joel. I have a PhD in mechanical engineering. My brother Seth has a PhD in math. We try to meet every day to go over an SAT math question to give insight as to the concepts behind it, and often offer different ways to do the problem. Here there are at least 2 ways to do the problem. It's important to understand the concepts behind all these problems because we don't know exactly what exact questions on the test, but you know the concept. These concepts will be on the test. You have to know how to do a linear equation word problem in the SAT. Absolutely need to do it. If you need extra practice, go to Khan Academy. They have the topics are sorted by the work. The review is sorted by topics. So go to the topic that you want help in and study that. And of course, take all the Blue Book tests and learn from your mistakes. So I guess we'll keep it short today at the end. Please leave comments on our videos. We take all the videos very seriously. We try to take all the comments very seriously. We try to respond to each one. And I guess that's it. Anything else, Seth?
No.
Okay, great. Okay, so carry on. Practice. Learn from your mistakes and get better each day. Take care, everyone. Have a good day. Bye.
Okay.
Bye.